In a previous video, we looked at what variation is, and the variation in that video was defined as the relationship between two or more quantities, where variation shows or depicts an increase in one quantity would mean an increase in the other quantity, or maybe an increase or a decrease. And in that same video, we looked at the types of variation. We said that we have direct variation, we have the inverse variation, we have the joint variation, and the the partial variation. We're going to look at direct variation in this video. And what is direct variation? This shows proportionality. It means that increase in one quantity leads to increase in the other, and decrease in one leads to decrease in the other. It is represented as A varies directly as B, or A varies as B, or A is equal to KB, where K is the constant of variation or the constant of proportionality. So if we have A varies as B, or A varies directly as B, it tells us that if A is increasing, B is also increasing, and when A is decreasing, B is also decreasing. So if you have to plot this relationship, you are going to have a straight line graph of this nature. So if you say that this is A and this is B, so as A, as you go up along the vertical axis, you're also going further along the horizontal axis. So as A increases, B increases. So you don't have a straight line from the origin, which is O. Then another thing is that how do we represent variations? So take A varies as B. Mathematically, this varies as we change in place of the variation sign, we put our equality sign, and we introduce our constant proportionality. So A varies as B is represented as A is equals to K times B. Now our constant of proportionality is not restricted to K. You could use any letter for the constant of proportionality or the constant of variation, but usually mathematicians prefer K to represent the constant, but as we proceed, we may be using other letters to represent it. So this is the way to represent it, especially direct variation. So it can be Q varies as S. So if Q varies as S, that means Q is equals to, when you introduce the constant Ks. So first of all, in most questions, you would need to look for the value of K. And how do you do that? You make K the subject formula. How do you do that? You make S from here. So you're going to divide both sides by S. So make Q over S. This way you look for the value of K. And then some questions will tell you to look for the formula connecting Q and S. To get the formula connecting Q and S, get the value of the constant, which is K, then substitute the value into this formula again. Then you get the formula connecting K, connecting Q and S. The examples I'm going to take will show how. In fact, there will be examples that will carry on this what I'm trying to illustrate here. So let's dive into examples. Number one, if P varies directly as R and R is 12 when P is 10, find the relationship between P and R. So first thing we're going to do is to represent this statement P varies directly as R in mathematical form. So that P varies directly as R. So that's it. This way you represent direct variation. Okay, so next is to bring in our equality sign, and then our constant of proportionality multiplied by R. The next thing is we're going to find the value of K, because the question says the relationship between P and R. So to get K, the question provided value for 12 and value for P. So say when P is equals to 10 and R is equals to 12. K will be P equal to Q. You could solve like this by substituting the values for P and R into where you have P into P and R here. But let's okay. You can also solve by making K the subject formula first. So if you say P is 10 is equals to 12 K. So K is equals to 10 or 12. 2 here, 5, 2 here, 6, which is 5 over 6. Or you could say P is equals to Q. Make Q subject formula. Q is equals to P over R, where P is equals to 10 and R is 12. 2 here, 5, 2 here, 6. So Q is equals to 5 over 6. Either way, you get the same answer. So the formula is, now you come back to this formula again, and you write it P is equals to, in case of Q, you put the value you gotten from it, 5 over 6 R. So therefore, the relationship between P and R is P is equals to 5 over 6 R. That's the relationship. So this is R A. B says R when P is 6. So you write the formula again, P equals to 5 over 6 R. So when P is equals to 6. So if we make R the subject formula first, or just solve right away. So let me put the value 6 equals to 5 over 6 R. So I'm going to multiply both sides by 6. Multiply both sides by 6. So 6 times 6 equals to 5 over 6 R times 6, 6 and 1, 6 and 1. So 36 equals to 5 R. So divide both sides by 5. R is equals to 36 over 5. And that will give us R is equals to 7 over 1 over 5. So when P is 6, R is equals to 7 over 1 over 5. That's number 1. Number 2. The value of A varies directly as the square of B. So A varies directly as the square of B. When A is 3, B is 2, we're going to use these values to get our constant. E is equals to K B squared. And we need to get the value of the constant because that's what will help us to get the relationship between A and B, which is the A part. So let me write A part here. So A equals to K B squared. So K is equals to A over B squared. When A is equals to 3 and B is equals to 2, K will be equal to 3 over 2 squared. That's 3 over 4. So that's the value of K. So we'll put this value into this formula. So let me just put this 1. So now I've got the value of K. So I say substitute the value of K into 1 in order to get the relationship between A and B, not to get the relationship between A and B. So 1 is A is equals to K B squared, where K is equals to 3 over 4. So therefore E is equals to 3 over 4 B squared. So that's the formula connecting. So this is the relationship between A and B. So B says E when B is 3. So when we write our formula, E equals 3 over 4 B squared. So now we're looking for the value of E when B is 3. When B is equal to 3, E is equals to 3 over 4 3 squared. E is equal to 3 over 4 times 3 squared means 3 times 3. 3 squared is equal to 2 times 2. 2 should multiply itself 2 times. That will give us 9. So we can say 9 over 1. That's equal to 2 times 9, 27 over 4. Which can express as 6 over 3 over 4. Therefore, E is equal to 6 over 3 over 4 when B is 3 and K is 3 over 4. And C says B when A is 12. So write our formula again. A is equal to 3 over 4 B2. So when B is equal to, okay, when E is equal to 12, B would be, so we make B, oh, okay, so 12 is equal to 3 over 4 B squared. So eliminate 4 from the multiply both sides by 4. Multiply both sides by 4, or negative over 1, then cross multiply. So on multiply both sides by 4, give 12 times 4 plus 2 over 4 B squared times 4, 41. 41. So 3 B squared is equal to 12 times 4. Divide both sides by 3. B squared is equal to 12 times 4 over 3. 3 here 1, 2 here 4. So B squared is equal to 4 times 4. B squared is equal to 4 times 4 is 16. So eliminate the square root. To remain the square root, take square root of both sides. Take square root of both sides. So B squared root equals to square root of 16. So B is B is equal to square root of 16 is 4. So B is 4. Let me show you. If X varies directly as Y, so let's introduce this sign and KY. So X equals to 5, Y equals to 15. What is Y when X is 1.5? For us to solve this part from this part here to get Y, we first want to get the constant of proportionality, get the value of the constant. We need to get the value of K, which is the constant of proportionality. So once we get it, we derive the formula connecting X and Y, and then from there we get the value of Y when X is 1.5. So first thing we need to do is we can only get K, which is the value or which is the constant proportionality, by using this part of the question, this values given for X and Y. So when X is equals to 5 and Y is equals to 15, K is equals to 5 is equals to 15 K. So to get K, divide this side by 15. So K is equals to 5 over 15. 5 over 1, 5 over 2, which is equals to 1 over 2. So let's get the formula connecting X and Y. So if we call this equation 1, so say substitute value of K into equation 1 to get the formula connecting X and Y. So X is equals to, so where we have K, we put the value 1 over 3 formula theory y. This is the formula connecting x and y. So what is y when x is, so when x is, when x equals 1.5, then y is, so then it's 1.5 equals 1 over 3 y. So multiply both sides by 3, 1.5 times 2 is equals to y. And y is equals to 1.5 times 3, 1.5 times 2, 3 times 5, 15, 3 times 1, 3 plus 1, 4. So 4.5, so y is equals to 4.5. The time of oscillation of a pendulum varies as the square root of its length. So let's take note, the two quantities that are varying here are time of oscillation and the length of the pendulum. So the time of oscillation of a pendulum varies as the square root of its length. So time t varies as the square root of its length. So this equals to k square root of length. So the next thing is to look for the constant of proportionality, which is k. Now to do that, let's look for the values of t and that of length. So if the length of the pendulum, which oscillates for 35 seconds, the time is 35. So when t is equal to 35 seconds, it's 49 centimeters, and length is 49 centimeters, then k is equals to c over square root of l, which is equals to, our time is 35 square root of 49. That's equals 35 over square root of 49, 7, and 7 here 1, 7 here 5. So our k, value for k is 5. Now we're going to put 5 in place of k to get our formula. Therefore the formula connecting c and l is, c and l is c equals to 5 root l. Now the question says, find the time of oscillation of a pendulum with length 121 centimeters. So when L is equals to 121 centimeters, the time of oscillation is equals to 5 times root 121, and t is equals to 5 times square root of 121 is 11, so t is equals to 55 seconds. Number 2. G varies directly as a square of h. G varies directly as a square of h. So G is equals to G h squared. If G is 4 when h is 3, that means we're going for the constant of proportionality first before we can get h as when G is 100, which is the second part of the sentence. So K is equals to G over h squared. So we'll come here. When G is 4 and h is 3, Q is equals to G 4 over 3 squared, and 3 squared is 4 over 9. Therefore, was G equals to 4 over 9, h squared is the formula is the formula connecting G and H. Connecting G and the square of H. Next is come back to here. So find H when G is 100. So this is the same formula. When G is 100, H is G 100 equals to 4 over 9 H squared. So multiply both sides by 9. So 9 times 100 equals to 4 H squared. So divide both sides by 4. H squared equals to 9 times 100 over 4. And take to eliminate the power 2. And take square root of both sides. Take square root of both sides. Square root of each squared. Square root of 9 times 100 over 4. So cancel this. So each the square root of 9 is 3. Square root of 100 is 10. Square root of 4 is 2. 2 here, 1, 2 here, 5. So 5. So 3 times 5, which is equals to 15. Therefore, each is equals to 15. The electrical resistance R in of a piece of wire is proportional to its length L meters. So the two quantities that are proportional or connected to each other is the resistance R varying directly as the length L. So R is equals to Q L. Question 1. So so a piece of wire of length 12 meters has resistance 25 ohms. So write figure 1, write the equation connecting R and L. To get equation connecting R and L, this is the equation, but we need to know the value of Q. So to get the value of Q, we're going to say when R, or before we get the value of Q, let's make Q the subject formula. Q is equals to R over L. So Q is the subject of the formula. So when R is 25 ohms and L is equals to 12 meters, and L is 12 meters, K is equals to 25 over 12. So the formula connecting, we're going to just substitute the value of Q. Substitute the value of Q in equation 1 in place of Q. So when we have Q, put this, so R is equals to 25 over 12L. Therefore, the formula connecting R and L. Therefore, the formula connecting R and L is R is equals to 25 over 12L. 25 over 12L. Formula figure 2 is formula figure 1. Formula figure 2 says find the length of wire for a resistance of 40 ohms. So we write the formula again. R is equals to 25 over 12L. So when R is equals to 40 ohms, so it means 40 is equals to 25 over 12L. 25 over 12L. We multiply both sides by 12. Multiply both sides by 12. 40 times 12 is equals to 25L. So divide both sides by 25. Divide both sides by 25. So 25L over 25 is equals to 40 times 12 over 25. So L is equals to 5 here, 5, 5 here, 8. 8 times 12, that's 96 over 5. Is 19.2 meters. 19.2. Therefore, L is equals to 19.2 meters. So okay, the table below satisfies this relation y is equal to k root x, y is equal to k root x, where k is a positive constant. So A says find the value of k. To get the value of k, make k the subject formula. K is equals to y over root x, and we can get the value of y and x from this table. So we can pick from here or here. So let's pick from here. So when x is equals to 1 and y is equals to 0.5, k is equals to 1 over k is equals to 0.5 over root 1. That's 0.5 over 1. So k is equals to 0.5, which is also equals to 1 over 2. So the formula connecting y and 8x is therefore the formula connecting y and root x is y is equals to 1 over 2 root x, or you say y is equal to 0.5 root x. Then the other part b says find the value of p. So to get the value of p, we're going to use this part. Now p is equals to x, so x is equals to p, and then the formula here is y is equals to half root x, where x is equals to p, and y is equals to 2.5, where x is equals to p, and y is equals to 2.5. So 2.5 is equals to 1 over 2 root p, and root p. So multiply both sides by 2, multiply both sides by 2, 2.5 times 2, so 1 over 2 root p times 2, 2, 1, 2, 1. 1 times root p is root p. Root p is equals to 2.5 times 2. Root p is equals to 2.5 times 2. 2 times 5, 10. Carry on. 2 times 4 plus 1, 5. That's 5. That's 5. 5.0 is 5. Now to get the value of p, we're going to square both sides. Square both sides. So root p square is equals to 5 square 2 for the new square root side. So p is equals to 5 times 5, and p is equals to 25. So the value of p is 25 in this table. So q varies directly as the cube of p. Q varies directly as the cube of p. P raised to the power 3. So q is equals to q p3. So if we get q, let's call this equation 1. So q is equals, let's say from 1 q is q over p raised to the power 2. That is when we make q the subject formula. Now when p is equal to 1, q is equal to 3, so meaning with this information, this first information, we're going to get the value of q. So q is okay. So when q is equal to 3 and p is equal to 1, q is equal to 3 over 1 raised to the power 3, that's 3 over 1. So q is equal to 3. So if you substitute this value into 1, put 3 in place of q, in 1. So if you substitute this value, this 3, in place of q in equation 1, you're going to have q equals 3 p raised to the power 2. So that's the formula connecting q and p. So when q is 24, from this formula, q 24 is equal to 2 p raised to the power 2. So to make p to a solid formula, we divide both sides by 2. 24 by 2, 2 here 1, 2 here 8. So p raised to the power 3. So p raised to the power 3 is equal to 8. From indices, p raised to the power 3 is equal to 2 raised to the power 3. Since the powers are the same, then p is equal to 2. The value of p is 2. If p varies directly as a cube root of q, p varies directly as a cube root q, cube root of q, so p is equal to q cube root of q. So we then get the value of q. Equation 1 is from 1, q is equal to p over cube root of q. So when p, so get the value of q, the first part of the sentence where the values of p and q are given is what we're going to use. When p is equal to 3, and q is equal to 125, q is equal to p, which is 3, over cube root of 125. Cube root of 125 is 5. So therefore q is equal to 2 over 5. Q is over 5. And this also implies that the formula connecting p and q, p and the cube root of q is p equals to 2 over 5 cube root of q. Now the question says find q when p is 18 over 5. So when p is 18 over 5, q would be q times 3 over 5 cube root of q. So when p is 18 over 5, it means 18 over 5 is equals to 3 over 5 cube root of q. Okay, so 3 over 5 is 10 over 5. Okay, so what we're going to do is we're going to cross multiply. Cross multiply. So 18 times 5 equals to 3 times 5 cube root of q. So this 18 times 5 equals to 15 cube root of q. So divide both sides by 15. So cube root of q equals to 18 times 5 over 15. So the cube root of q equals to 5 here 1, 5 here 2, 2 here 1, 2 into 18, 6 times 6. So the next thing is to raise both sides. Raise both sides. So the power of 3. So the power of 3. You have to eliminate this cube root sign. So this will give us cube root of q raised to the power of 3 equals to 6 raised to the power of 3. So 2 here 1, 2 here 1. So q is equals to 6 raised to the power of 3. Nice. 6 raised to the power of 3 is 6. 6 times 6 times 6. 6 times 6 is 36. Times 6 is equals 6 times 6, 36. Carry 3. 6 times 2, 18. 18 plus 3, 21. That's 260. The rationale here is that from our fractional indices, cube roots of 3q is called 3 is equals to q raised to 1 over 3 or raised to the power of 3. 2 times 1 is 2, so q 3 over 3, 3 over 1, 3 over 1. The q is equals to 1 divided by 1 is 1, and q raised to the power 1 is q. So 2 divided by 4 root of q will give you q. So from indices, we get same answer. So q, the value of q is 216. If a is directly proportional to b, so a is equals to q. Okay. From 1, k is equals to e over b. So when k is equals to minus 1 and k is equals to minus 4, k is equals to minus 1 over 4. So the formula connecting a and b is writing k. A is equals to 1 over 4 b. Therefore, the formula connecting a and b is equal to 1 over 4 b. Number 2. Y varies directly as an unknown power of x. Express y as a function of x, given that when x is 2, y is 0.4, and when x is 4, y is equal to 6.4. Take the unknown power of x to the n. So the first part of the sentence is y varies directly as an unknown power of x. So we say y varies directly as x raised to n. N because the last part of the sentence is we should take the unknown power of x to the n. So this will give us y equals to q x raised to power n. Equation 1. So from 1, k is equals to y over x raised to power n. So where x is 2, where x is 2 and y is equals to 0.4. k is equals to k is 0.4 over x over 2 raised to n. 2 raised to n equation 2. Then where x is equals to where and when x is and when not where when x is equals to 4 and y equals to 6.4 q equals to 6.4 over 4 and equation 2. We can't stop here because we don't know n. We need to know n. We need to know the value of q because the question says we should express y as a function of x, meaning that we should find formula connecting y and x together, where x is to be where x is to be raised to the power of n, So we need to know n, which x will be raised to, and then we need to know the value of k so that we can find the formula connecting k. So find the formula connecting y and x raised to the power of n. Increase equation 2 and 2, because equation 2 k is equals to 0.4 over 2 raised to the power n, and equation 2 k is equals to 6.4 over 4 raised to the power n. So both equations are equal to k, so that means they are the same. They'll be equal to each other since they are all equal to k. So that's why we're equating 2 and 2. So 0.4 over 2 raised to the power n is equals to 6.4 over 4 raised to the power of n. Okay, so next is cross multiply. So 0.4 times 4 raised to the power n, 6.4 times 2 raised to the power of n. The next one I'm going to do is I'm going to divide both sides. So 4n, okay, 4 raised to the power of n divided by 2 raised to the power of n is equals to 6 over 6.4 divided by 0.4. So this will give us 4 raised to the power of n divided by 2 raised to the power of n will give us 2 raised to the power of n, because 2 into 4 will give us 2. So raised to the power of n, or better way to understand this is this. Okay, 4 raised to the power of n over 2 raised to the power of n. And this here 4 raised to the power of n, 2 raised to the power of n. You can write it as 4 over 2, since the power to which both numerator and the denominator are raised is the same. So factor it out. So 2 here, 1, 2 here, 2. So equals 2 raised to the power of n. So 2 raised to the power of n, then 6.4 divided by 0.4, 16. From indices, to n is equals to 2 raised to the power of 8, 2 raised to the power of 4, because 2 times 2 times 2 times 2, 2 times 2 is 4, 2 times 2, 4, and 4 times 4 is 16. So 2 raised to the power of 4. Since the bases are the same, therefore n is equals to 4. So now that we know n to the 4, let's put the value of n into any of this equation to get q. So substituting 4 for n. That's equation 2. Equation 2, 6.4 over 4 raised to the power of 6.4. 4 raised to the power of 4 is 256. So 6.4. Convert this to whole number to 64. So here we go 1, 2, 5, 6, 7, 64 here, 1 also here, 40, which is equal to 1 over 40, 1 over 40. So we've gotten the value of k, and we've gotten the value of n. Since the question said we should express y as a function of x, means that we should find the formula connecting y and x, n. So the formula is y is equal to k, y is equal to kxn. So I say from 1, y is equal to k, kx, kx raised to the power n, where x is equal to, where k is equal to 1 over 40 and n is equal to 4. So y is equal to 1 over 40 x raised to the power 4. Therefore, the formula expressing y as a function of x raised to the power n is y is equal to 1 over 40 x raised to the power 4. That's the formula. The electrical resistance R ohms of a wire varies directly as the length LCM. So resistance varies directly as the length R is equal to QL, equation 1. So from equation 1, K is equal to R over L. When so R, if R is, when R is equal to 0.6 ohms and L is equal to 35 and L 7.5 centimeters. 7.5. So K is equal to 0.6 over 7.5 is equal to 0.08. Put 0.78 in place of Q in 1. So R is equal to 0.08 L. The formula connecting R and L is R is equal to 0.08 L. So if, okay, so find R when L is at 5.5. So when L is 35.5 cm, R is equal to 0.08 times 35.5. That's 2.84 ohms. So the rate of consumption of petrol by a vehicle varies directly as the square of the distance covered. So let's represent the rate of consumption by C varies as the square of the distance covered. So C is equal to K D squared. Expression 1. So from 1 K is equal to C over D squared. So when C is equal to, if 4 liters of petrol, 4 liters, and times 15 kilometers, so Q is equal to C, 4 over 4 over 4 over 15 15 squared plus 4. 15 squared is 225. So put 4, 225 in place. Q in equation 1. So Q C is equals to 4 over 225 D squared. D squared. Therefore, the formula connecting C and D squared is equals to 4 over 225 D squared. The next is, so how far would the vehicle go on 9 liters of petrol? So we say when C equals to 9 liters, so D will be 9 is equals to 4 over 225 D squared. So multiply both sides. Multiply both sides by 225. So 9 times 225 is equals to 4 D squared over 225 times 225. So 4 D squared 9 times 225. Divide both sides by 4. D squared divide both sides by 4. D squared equals 9 times 225 over 4. So take the square root of both sides. Take the square root. Take square root of both sides. D squared 9 times 225 over 4. D squared. D squared. Here it goes directly from here. 9 square root of 9 is 3 into square root of 225 is equals to 15. Square root of 4 is 2. Or you just say square root of 9 times square root of 225 over square root of 4. This is 3 times 15 over 2. And here 2 here, the cancel. So D is equal to 3 times 15 is 45 over 2. So 45 divided by 2 will give us 22. 5 divided by 2. 22. It's over 1 over 2. 22 over 1 over 2 centimeters. That's 2.5 centimeters.